February 16, 1943. The screwdriver trembled slightly in Oberingenieur Klaus Herrmann's hand as he loosened the final screw on the sealed metal casing of the captured American radio set. The lab was silent except for the faint hum of overhead lights. Around him, 5 of Germany's top communications engineers leaned closer, anticipation etched across their faces. The device before them had been seized from the Americans during the fierce fighting at Kasserine Pass, the first major clash between U.S. and German forces in North Africa. For months, the engineers of the German High Command had been trying to understand how Allied field communications had become so sophisticated. Their own systems were reliable, but increasingly, German intelligence officers reported that the enemy's coordination seemed faster, their air support more precise, their artillery responses nearly instantaneous. Something had changed in Allied radio technology, and now, for the first time, they had the proof sitting right before them. Klaus carefully removed the final panel, revealing a maze of wires, polished coils, and unfamiliar circuitry. "This," he murmured, "isn't like anything we've built." The others exchanged glances. They were experts in shortwave and long-range communications, veterans of Germany's most advanced research programs, yet even they could see the difference immediately. The compact design, the unusual arrangement of vacuum tubes, and the precision of the internal components suggested an innovation far beyond standard Allied equipment. Outside, snow fell gently over Berlin. Inside the laboratory, the air grew tense with both excitement and unease. The device was an SCR-300, one of the first truly portable FM radios ever developed, known to American troops as the walkie-talkie. To the German engineers, it represented a revolution in the way the enemy fought its battles. For years, German field units had relied on AM radio technology, which was vulnerable to static, interference, and enemy listening. But this was different. The FM signal was cleaner, harder to jam, and could maintain clarity even through the smoke and chaos of battle. As the engineers dissected the radio piece by piece, they began to realize the magnitude of what they were holding. Each circuit and transformer told a story of ingenuity. They noted the careful attention to shielding and the compact transmitter-receiver integration that allowed soldiers to communicate clearly across miles. The technology was American, yes, but the precision hinted at something else, something perhaps British in origin, or maybe even influenced by pre-war European designs. Klaus jotted notes feverishly as the senior engineer, Dr. Otto Werner, examined the antenna assembly. "If this design is standardized," Werner said softly, "it could change everything on the battlefield." The others nodded. They understood. For the Wehrmacht, communication had always been both a weapon and a weakness. Their blitzkrieg tactics depended on speed and coordination. Yet, as the war dragged on, radio interference, Allied jamming, and technical limitations had started to erode that advantage. Word of the discovery spread quickly through the German military's intelligence and research divisions. Within days, the radio was shipped under heavy guard to Berlin's Telefunken research laboratories, the very heart of Germany's wartime communications technology. There, a special team was assembled under direct orders from the Ministry of Armaments, led by Albert Speer himself. Their mission was clear: reverse engineer the American device and produce a German equivalent as quickly as possible. But that was easier said than done. The Allies had achieved something the Germans hadn't anticipated: the perfect balance between mobility and reliability. The SCR-300's creators, engineers from Motorola and the U.S. Signal Corps, had designed it specifically for the rugged conditions of modern warfare. It could operate in snow, mud, and heat, powered by lightweight batteries that kept soldiers connected without the bulky field sets of earlier years. Inside Telefunken, Klaus and his colleagues worked tirelessly. Day and night, they analyzed every solder point, every resistor, every wire. The challenge wasn't just understanding how it worked. It was replicating it under the constraints of Germany's collapsing industrial base. Copper was scarce. High-quality vacuum tubes were in short supply, and Allied bombers were already targeting key electronics factories across the Reich. Still, the engineers persevered. By late 1943, they had developed a prototype, the Feldfuu B, Germany's answer to the American walkie-talkie. It was a technical marvel by any measure, but heavy, fragile, and notoriously difficult to maintain in the field. Unlike the SCR-300, it required precise tuning and constant calibration. In the chaos of the front, it was nearly impossible to keep it running reliably. Yet even this imperfect copy told a deeper story. The story of how technological innovation was reshaping the war itself. For centuries, victory had belonged to those with the biggest armies or the boldest strategies. But now, in the 20th century, it belonged increasingly to those who could communicate fastest, coordinate most effectively, and outthink the enemy in the invisible world of signals and frequencies. As 1944 dawned, Germany's engineers watched with growing alarm as Allied radio networks expanded exponentially. American tank columns moved with uncanny precision. Airborne divisions coordinated strikes with pinpoint accuracy. What the Germans once considered tactical chaos was now organized warfare on a level they had never experienced. Every signal sent over Allied frequencies was a reminder that the war of machines had become a war of minds. In Berlin, Klaus continued his work as the war turned against Germany. He watched as new directives came in. Frantic efforts to jam Allied broadcasts, to disrupt the very communication systems he had once admired. Each passing month, the reality became clearer. The future of warfare would not be decided by tanks or artillery, but by circuits, wires, and the men who understood them. By the time the war finally ended, the laboratory at Telefunken was in ruins. The once bustling research center lay silent, its equipment smashed or looted, its engineers scattered. Klaus himself was captured by advancing Soviet troops. Ironically, it was his knowledge of radio design that saved him from imprisonment. The Soviets, eager to match Western communication systems, recruited many of Germany's top radio engineers into their post-war scientific programs. Across the Atlantic, the Americans studied the captured German prototypes with equal fascination. They realized that their own technology, once so advanced, had inspired a global race. Within a few years, the innovations born in wartime secrecy would evolve into peacetime progress. The foundation for the transistor, for long-range telecommunications, and eventually for the wireless revolution that would connect the entire world. For Klaus, the memory of that cold February morning in 1943 never faded. The moment when he first opened the American radio marked the beginning of a new era. An era where power would no longer be measured by armies and empires, but by information. The walkie-talkie, once a simple field tool, had become a symbol of something much larger. The dawn of the communication age. And though the world around him had fallen into ruins, the idea it represented would endure. That even in the darkest days of war, human ingenuity could still find a way to connect.